there. Today we're going to be talking about the methods used in the aging of ribs by forensic anthropologists. My name is Anna Steinberg-Abreu. So when we first start out talking about age at death estimations, we really want to understand why that is so important. So it is important to have an accurate estimate of the age at death of an individual because that does help us compile a biological profile and can help us match up who that individual may have been, as well as it could be used in the judicial process. So there are a number of features that anthropologists use when they're estimating age at death, and those can include the pubic symphysis, teeth, as well as cranial sutures. Some of the drawbacks to using those methods is that teeth and the pubic symphysis can be fragmented and you can also lose teeth, so it does make it a little bit more difficult if we are missing parts or they are broken. And those do take a significant level of expertise to make sure you're making accurate estimates. The reason why the rib can be so helpful is that there are 24 of them. We have due to the sheer number of them, there's just a higher probability that we will find ribs with remains, and then also the fact that so a lot of methodologies that have been used in order to estimate age at death using ribs is that we can use fragmented ribs too. So if we are missing some or we have some that are not in very good condition, we can still potentially perform those methodologies on them. And it's also important to note that because these estimations and these biological profiles have the potential to be used in judicial processes and the identifying of missing persons, we really want to ensure that there is standardization and accuracy with the predictions. And there's a lot of legal and personal reasoning behind that. We're going to go from there. So Iskan's method for age at death estimation is one of the older methods used, and it was developed in the 1980s, and it was used with white males and females from the United States. And they based this method off of observable morphological features of the fourth rib. And they divided those into phases. So each phase corresponds with an age range, and that goes from 0 to 8. And what they were really looking at was the pit formation of the costochondral junction and the texture and quality of the bone. A running theme that you're going to see with a lot of these methods is that they're looking at the amount of degradation the bone has gone through. So as we age, our body does degrade over time. So that is really important to keep in mind, as that we are looking kind of at how our bodies kind of degrade over time. So the limitations of the ISCAN method are that they were performed on a subsect of a group, so white individuals, and that has shown through validation studies to skew the results of other groups. So in the Cesar-Roman and Espinosa study, they found that there was a lot of underestimation using the ISCAN method on Mexican samples. They also noted that, different populations, reasoning behind this could be that different populations have different rates of degradation. So it's not a one-size-fits-all for the ways in which we categorize things and the age ranges that they correspond with. Another issue with limitation of the ISCAN method is that there's a degree of subjectivity associated with this method. It's really based off of observable features, and so everyone can kind of subjectively observe things a little bit differently, which may have an impact on the reliability of the estimation. It does require intact specimens, and you do kind of rely on a degree of expertise in order to make sure that the analysis is as accurate as possible. Another method for analysis is rib histomorphometry. So this method looks at the microanatomy of tissue and these specific features that are correlated to age. So in this method, it's going to include the counting of intact and fragmented osteons, as well as measuring the total area of the osteon and the population of the osteon. And so this method is a lot more destructive than the ISCAN method, and it doesn't involve the cutting and grinding of bone in order to expose that tissue that we want to look at under the microscope. This was performed on the midshaft of the sixth rib, but the studies did say that they could use the fourth and eighth rib as well. So kind of anywhere in between the fourth and eighth rib are all potential areas where you can perform this form of analysis. Some limitations of using rib histomorphometry is that it does rely on a predictive formula about that are population specific. And this is another running theme that you'll see with a lot of these studies, is that the formulas that are created for these groups are very reliant on the population that they were created with, so the sample population that was used to create the predictive formula. So they found that in the Garcia-Donas study, they found that there was another underestimation with the older groups, and then an overestimation in the younger groups. And so they found that in order to make sure that you're making reliable and accurate predictions, you really need to have a predictive formula that is associated with the population that you're trying to estimate the bones for. And then this also does require a degree of expertise in order to carry out the specific analysis. So you need to be able to properly cut the bone, preparing the slides, correctly identify the osteons and classify them as well. Another method for analysis is the analysis of cortical rib bone matrix. This analysis really looks at multiple methods, so it's a multifactorial method, and it looks at the physiochemical and mechanical factors that are present in rib bones. So again, they're looking at the degradation of the bone. So theirs looked at porosity, histomorphology, water content, thermal analysis, and nanoindentation and microindentation. So a lot of different features that are associated with the aging process. The really good thing about this form of analysis is that it is experience independent. They found that really anybody who performed this did not need to have a background in forensic anthropology or anatomy. So a physicist, a chemist, really anyone could really carry this out. And they found that the absolute error was 4.64 years old. So that's a pretty good range for age estimation. Obviously, it's not exact. And then it is not as subjective as morphological methods, so similar to the ISCAN method. It does not do that. It's quantitative. It's really looking at empirical evidence rather than looking at subjective observable traits. Limitations to the bone matrix analysis is that it did not account for the effects of sex or BMI on the degradation of the bone and what that might reflect in terms of age. It also doesn't look at the genetic factors and variability across populations. So again, like we said before, different populations may show different rates of bone remodeling, different rates of degradation, as well as environmental factors that may also have an effect on that. And again, all of that comes down to is it may skew our results in creating an accurate prediction and estimation of age at death. Another method for analysis is the study of the pigmentation in the costal cartilage. So, for the costal cartilage, it is an observable feature where the coloring does change over time as we get older. So, this study looked at the second costal cartilages, and you can see that on the picture there, A that's going to be for a much younger individual, so the costal cartilage is white. But as people age, they do seem to go more yellow or brown. Um, and so we're looking at that pigmentation change over time. And they were able to quantify this using the mean gray scale. And then this also can be, but some of the drawbacks is this can only be used for individuals between the ages of 20 and 60, rather than individuals who may be a little bit younger or older than that. And then they felt that this was a very practical method for analysis with an absolute deviation of 4.42 years of age, or and 3.57. So that's still a pretty good predictive range. Some limitations are that it is only suitable on mortal remains, so it's going to be a lot harder to do that on skeletal remains, as that costal cartilage is going to see a lot more changes over time as the body decays. Again, like I said before, it does not work for specimens that may be under the age of 20 or older the age of 60. There's also the possibility of abnormal pigmentation that would definitely skew the results. And then there also is the issue that, nutritional deficiency and other environmental factors may also play a role in the way at which the pigmentation changes over time, and how slowly or rapidly that may occur, that could not necessarily accurately correlate with the person's actual age at death. Another method for analysis is the utilization of CT imaging to estimate age. So this is going to do 3D modeling, and it's really going to focus on the ossification at the chest plate. So ossification does begin at the teenage years, and to understand what ossification is, it really is the remodeling of bone over time. So it's the laying down of new cells over each other as time progresses. And it does continue throughout adulthood. And the really positive aspects of using CT imaging is that it gives you a 3D picture. It is quick and it is non-invasive, and CT imaging machines are a little bit easier to come by, although, not necessarily when you're thinking about rural areas. It's gonna look at, they found in this study that the sternal end of the rib had the highest correlation with age, so they really wanted to focus on that compared to other features of the bone that might not correspond as heavily or directly with age. And they did compile a scoring method to categorize and determine the age-related ossification, similar to the ISCAN method. Limitations of the CT imaging to estimate age is that it is not proven to be as accurate as other methodologies for estimating age, like rib histomorphometry, or using the physiochemical and biomechanical, methods for analysis. It does rely on morphological features rather than quantitative features, and then it does also need a level of expertise in order to make sure you're really accurately identifying the ossification and measuring that accurately. So overall, it's really important to understand that in order to create viable information, these methodologies do need to be sound. And in order to do that, a huge effort does need to be taken under in order to provide standardization and make sure that we are being population specific so that we are ensuring accuracy. Like we said before, different populations do seem to reflect different rates of degradation, even within a small degree. And it is becoming a more common method to use the ribs as a way to identify someone's age at death. And there does seem to be a shift from methodologies like the ISCAN method to more quantitative and technologically intense approaches similar to rib histomorphometry, as well as the physiochemical and biomechanical approaches. And as you can see, there really is not a golden approach yet that provides both precise and accurate age at death estimations for ribs. But I think we can be sure that as time goes on, as technology advances, and as we become more standardized in our methodologies, that this could become something that we will get closer to. Thank you very much.